What shape is this? What? Okay, I want to show you the basic. Has anyone seen the equation of a circle? Maybe I feel like sometimes in grade 9 it shows up. Watch this. I'm going to write it here, but I want you to.
Please excuse the interruption. At this time, we welcome staff and students scheduled to view assembly number 3 to Lismer Hall. Again, staff and students, assembly number 3 to Lismer Hall, please. Thank you.
All right. So this is a very interesting equation. The equation of a circle is y squared plus x squared equals something. Let's say 25. Okay? What is unique about this equation? Like, what have you not seen yet in this equation? Like, we've seen parabolas, right? Yeah, Corley. Yeah, both of them are squared, y squared and x squared. That's kind of unique. Now, let's connect this graph to today's lesson. Okay, so we talked about relations, and relations are just a set of points. Are there points on this green graph? How many? Not a bunch, even more. More. Infinite. Do you know what infinite means? There are so many we can't even say the number. Okay? Because watch. Point, right? As long as you have a line, any kind of line, you have an infinite number of points. Now, so is it a relation? Does it have a set of points? Yes, no. Everyone's going to vote. If you get it wrong, no problem. Is this a relation? Everyone. Oliver, I need your thumb up or down. Okay, yes, it's a relation. There are a bunch of points. Is this a function? Okay. Does it pass the vertical line test? Meaning it's not a function. Right? So if I draw a line straight down and I touch, and then I touch again, not a function. Yes, a relation, not a function. Now, I want to show you something called transformations. Okay, so you've already started. You did a little bit, the first day that I was here, that Mr. Alexander did an introduction to transformations with you, where you were taking a line and you were transforming it. You were flipping it by 90 degrees, looking what it does, that kind of stuff. So we're going to do that too. So we're going to take okay, I'm going to change this to 9. Now, here's the thing. Do you know what the 9 or the 25 or the 16 do to the circle? So watch this. This is 16. This is 4. This is 9. Fallon. Yeah. So if this is 9, although no, it's not perfectly the diameter. But that is totally on track. Yeah, give me more, Oliver. It's the radius squared, right? So the actual equation of a circle is like this, that x squared plus y squared is the radius squared. Kind of cool. So let's stick with 9 for now, because I have this equation where I've added some numbers. I've never done this with a circle, but I'm just curious, what will happen if I add some numbers in that equation, right? So what will happen if I add a 1 next to the y? Interesting. What will happen if I add a 1 next to the x? I want everyone to guess. So make a circle and just take a guess what will happen to the circle. And I have no idea. So we're all just guessing. Okay, having seen that the 1 moved it down, what's going to happen to when I put a 1? Let's see. Oh, wait. Interesting. Yeah, it's kind of interesting that it went the opposite way, right? what if, okay, now we know a bit of information. I'm going to put a -1 next to the x. Okay, so do your circle and show what's going to happen to it. Okay, is it going here? Is it going here? Is it going here? Let's see. So -1, so it goes the opposite way. Interesting. And so if I do -1 next to the y, what's it? So regular circle, everyone? Regular circle? Yeah, you can make a little circle, Kume, it's okay. Right? And what is the -1 next to the y going to do? Let's see. It goes up. Interesting. So when I add a number next to the y, what does it control? What does it do? Show me with your hand. What if I, instead of putting an actual number, I'm going to put a variable here. And I'm going to put a variable here. And I'm going to get a slider to start playing. So so what this slider is doing for me is just changing the k value. So that's the number next to the y. If I play oh wait, I want this to be 0. If I just have the h changing, it affects the x, right? What if I have both of them changing? Show me with your hand what you think is going to happen. So I'm going to have both x and y changing. Okay, I see movement. I feel like that's a, whoa, where'd you go? Interesting. I'm going to coordinate them. I'm going to get them to go to 0 and 0 and try to press play at a similar time. Oh, it's not letting. Interesting. It kind of makes this rectangle as both the x and y are changing. Okay. I'm going to add another thing. Now, when something is moving on the graph, up, down, diagonal, we call it a translation. Like transportation, translation. It's translating. Do you think a parabola could do it? Yeah, totally could. I'm going to add yet another one. I'm going to put an A in front of one of these. Okay. And I nicely have an A value ready to go. So let's see what happens when I start changing the A. Whoa. Holy guac. That's messed. Doesn't that feel like it's like 3-dimensional? Is it really bad that I don't know how it does it? Will you forgive me as a math teacher? Okay, that's cool. Okay, so now that we saw what happens when you put an A value in front of the Y part, what if I move the A in front of the X bracket? What do we think? Same, different, opposite? Okay, you ready to see? Okay, here's the opposite A. Ah, okay. So it just does the opposite. What if I add an A in front of both H and X and Y? Ooh, that's so cute. And it disappears. Whoa, that's like space. Kind of cool. Yeah? Yeah, cool. So we started off with a circle and we translated it up, down, diagonal. That's called a translation. We also stretched it and we compressed it. Okay, so we basically were changing the location of the circle, and then with the A, we were changing the shape of the circle. All of this we call transformations. Do you guys know Transformers? Transformers, robots in disguise. Yeah? Is that the song they still sing? Or is that from like the 80s? Okay. So you have a car that turns into a robot, and you're like, whoa, how did that happen? And you're like, it's math. It's a transformation, right? So we take a circle, we adjust some numbers, and it turns into something else. Okay, so we transformed it. Now, as exciting as it is, we are not going to be working with circles, folks. I'm sorry to say, because we are in grade 10. What we are going to work with is this wonderful shape. Okay, we're going to work with a good old parabola. And we're going to look at 3 types of transformations in the next 2 days. Today, we're looking at one transformation. Now, I want you to look at this equation that I have here. Okay, I've got 2 equations. The first equation, y equals x squared, we've seen before, right? How do I know it's a quadratic? What in this equation tells me it's quadratic? Yeah. Okay, the x is squared, it's a quadratic. Okay, we know that a quadratic equation on a graph looks like a parabola. Okay, so this is a basic parabola. Instead of calling it a basic parabola, in grade 11, we call it the parent function. Now, looking at this parabola, I just called it a function. Is that fair? Right, so let's check. Is the parabola function yes, no? Yes, thumbs up, no, thumbs down. Will it pass the vertical line test? Yes. Now, when you're drawing a parabola, do you know what mistakes sometimes students make? They actually make it into a relation. As they're drawing the I don't know what you would call it, the arms of the parabola as they're going out, do you know what mistakes students make? Show me. Show me a bad parabola, a parabola that is not a function. Oh, I'm seeing, oh, ow, oh, that hurts. Yes, they curve them in. So if I'm like this, is this a function? Fail. Or this is what I see more often. I see it starts nicely from the vertex and then just parallel lines. When you have a parallel line, a vertical line, that's not a function, right? Because all these dots have the same x value. So as we draw parabolas, what's happening to the arms is that they keep going out, out, out in the x-axis and up, up, up in the y-axis. Okay. Now, I've taken this equation and I've added some more variables that are my transformations. There's an A in the front. Who's seen the A before? We all have. What do we call the A? In Mr. Alexander's class, what did you call it? He's called it the acceleration term, right? Do you know what the A does to a parabola? Or not yet? Not sure. Not sure, Catherine? Okay, good, because I just need to know if I should teach you that. Okay, then there's an H. Oh, the H is inside the bracket. Oh, it's next to the X. Show me, what did when I had a number next to the X in the bracket for the circle, what did it do to the circle? Show me. Circle, and what did it do? Everyone. Oh yeah, it was moving horizontally. Interesting. Okay, let's see if that's the case for a parabola. And then today we're going to look at this K. So notice, the K is after everything. Okay? I want you to give me a parabola. Everyone. Everyone gives me a parabola. And I want you to take a wild guess. Don't worry if you're wrong. We're activating our brain. When I change the K, if I make it 1, 10, 100, negative 100, what is it going to do to this parabola? Is it going to flip it? Is it going to go like this? Is it going to squeeze? Is it going to jump around? Everyone's doing something. Something. Okay. Beautiful. Folks, pat on the back. You made an educated guess. So let's see. Now I'm going to take this K and I'm just going to hit play. So what does the K, what is the K doing? It changes the y-intercept. Take your parabola, show me. Now let's zoom out a bit. And I want you to tell me, does it change the shape? Does it squeeze it? Or is it just the parabola is going up and down? It's just going up and down, right? So all we're doing is we're taking it, and anyone remember the word? It's kind of like transportation when things are moving. We're translating the parabola up and down. Now, I'm going to make the K value, okay, back to 0. I'm going to make the K positive 5. So regular parabola, everyone, give me your parent parabola, parent function. If I go plus 5 for the K, is it going up or down? Everyone show me their guess. Beautiful. You all have a guess. Watch here. Plus 5. Boom. Goes up. Okay? If I write minus 7, give me your parent parabola, your parent function. What does minus 7 do to your parabola? Let's see if you're right. Minus 7. Boom! Congratulations. Okay. This is a translation. Is it a horizontal translation or a vertical translation? Vertical. It's a vertical translation, moving up or down. That is all that this K value does. So let's move to our note. Okay, we're going to go to page 3 and make some notes about what we've just discovered. Did you sign in? Great. Nice to see you. Okay, so today we wanted to discover the meaning or what K, this transformation does to our parabola. So you have 3 parabolas on this graph. Find the parent function. Where is the vertex of the parent function? At 0, 0. Folks, what do I call that point, 0, 0? The origin. Good. So when I want to talk about the vertex, I write V, 0, 0. Right? You don't have to write vertex. You just write V. Now let's also write the word parent function. Okay, you don't need to know it in grade 10, but you will thank me next year when your teacher starts throwing out the word parent function. You'll be like, okay, yeah, yes. Yeah, so the parent function is the equation without any transformations. So we haven't moved it up or down, haven't moved it side to side, diagonals. We haven't changed the shape. Yeah. So we've just discovered that the K value, which comes after the x squared, moves the parabola up or down. So if I look at this equation, x squared plus 3, how many steps up has this parabola moved? It's gone up 3. So how does that change the vertex? Because it's got to change it. Go ahead and write the vertex. And do the same for this parabola that has traveled down 2. Is it the x or the y that changes? Think about it. Is it the x or the y, everyone? Good. So the x stays at 0. We haven't moved left or right. And we've gone up 3. And the lower one, the x hasn't changed, and we've gone down 2. So I want to write here what it's called. It's called a vertical translation. Sometimes you might hear someone call it a shift. That's fine too. We've already done the vertex. And you know what the vertex is, right? Like has Mr. Alexander talked to you about vertex? People? Yeah. Should I review? We're good. Vertex is I'm curious how he explained vertex. Yeah. Okay. Yeah, so it is the max min, right? And the other thing that I sometimes think of the vertex, it's the point at which the direction of the graph starts to change. So it's like we're going down, 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 plateau, up, 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 up. Right? So the vertex is the point where it starts to, the direction changes. That's another way of looking at it. Yeah. All right. And then I think you talked about the axis of symmetry. Yes, no? Great. And did you learn to write the axis of symmetry as an equation? Beautiful. Okay. So if I look, so the axis of symmetry, nice opportunity to review, is the line that splits the parabola, that goes right through the center of the parabola. And if I were to fold the parabola on the axis of symmetry, it would fold on itself. Like origami, like if you're like folding it, it literally goes on top of each other. And that's because a parabola is symmetrical. And so in order to write the equation, I need to write the equation of a vertical line. So let's think about this. For a vertical line, is it x equals or is it y equals? So which one never changes? When I have a vertical line, is it the x value that never changes or the y value that never changes? What is it? The x. What is the x value for this orange line? It goes right through 0. Right? So if you want to, I always forgot. So for a vertical line, the equation is x equals, and for a horizontal line, you don't have to write this, but if this is a good review of how to write the equation of a vertical and horizontal line, I would add it in, right? Sort of like a side note. And then it's like, oh yeah, and the axis of symmetry is a vertical line, right? So it's helpful. And in all of these cases, because none of them have moved, none of them have translated horizontally, the axis of symmetry for every single one is x equals 0, x equals 0, x equals 0. The vertex changed, the axis of symmetry didn't. So let's write a conclusion. In conclusion, when y equals x squared plus k, k causes a vertical translation. When k is bigger than 0, meaning it's positive. Then how does the parabola move? Parabola moves up. And then when k is negative, so it's less than 0, I'm going to write the word negative, parabola is going to move down. The vertex of the graph is as such. The x is always 0. The y is whatever your k is. Because the vertex starts at the origin And if it moves up 3 spaces, that means now the y is 3. And the equation of the axis of symmetry is x equals 0. That did not change. Put your telephone away. Oh, that's not away. Silly, silly, silly. Yeah. Okay. So, yes.
What does it mean that says the vertex of the graph? Doesn't the graph have many different parabolas and then many different?
Oh, yeah. Sometimes in this case, graph means the actual parabola, right? Yeah, this is a Cartesian plane. The x's and y's are a Cartesian plane. The graph is the line that is drawn. So when we're talking about any parabola in general, we're talking, and we say graph, we mean that parabola. Yeah. Okay. Now, tomorrow, we're going to look at the other 2 variables. We're going to look at what the A does, and I think you've seen this, and we're going to look at what the H does, how it transforms the parent function. Okay? And then the day after, we'll spend some time, where's my table of contents? Table of contents. So tomorrow, we'll look at A and K. On Monday, we'll combine all of them. Oh, the H was supposed to be there. On Tuesday, we'll learn how to graph parabolas in 2 different ways. And then we'll have a quiz, okay, on all those lessons. Now, you have time to work on your homework. I encourage you to do so. So hopefully you've started these ones. And now you can go to 213 and work on K's. Now, it's going to ask you to, in the homework, you need to draw some graphs. So is there anyone that needs graph paper? Because for this unit, you absolutely must use graph paper. Cannot be lines. If you're using lines, I'm not going to count it as done. So I'm going to give you each 2 pieces of paper for today. Okay, if you need paper, come on up. And folks, go ahead and get started.